Your API returns 200. Okay, the order was never saved. Nothing was logged, and nobody finds out for 3 weeks. That is one component, configured one way, and it is the most expensive mistake in MuleSoft error handling. By the end of this, you will never make it. Here is what we cover. What is actually inside the error object, including the field almost nobody finds, which errors you can catch, and which ones no handler will ever save you from. On error continue, on error propagate and raise error, and the single question that tells you which one to use, how a global handler works and how flows inherit it, and then the layer most tutorials never reach. Error taxonomies, standard error envelopes, observability and governance, the way this is designed across 100 APIs. Everything you are about to see is a real API in Anypoint Studio, and I will stop on every single thing I talk about and mark it on the screen, so you always know exactly where to look. This is the application we are going to protect, one flow, called postorder flow, and it runs strictly left to right. Before we talk about a single error handler, you need to know what is on this canvas, because every decision later depends on where the failure happens, so I am going to stop on each component, one at a time, and mark it for you. Step 1. The HTTP listener, post/orders. This is the source of the flow, and that word matters. Everything after it lives inside the flow, so a flow error handler can catch it. But if the listener itself fails, the port is taken. TLS will not negotiate, the request cannot even be parsed into a Mule event that is a source error, and no error handler you write in this flow will ever see it. Remember that. We come back to it. Step 2. A flow reference named validate. This is not a copy-paste of logic, and it is not an asynchronous call. A flow reference runs the target inline, same Mule event, same thread, same transaction. And this is the part people miss: the same error path. If the referenced flow throws, the error surfaces right here at this arrow, as if the code were written in line. Click it and the properties panel tells you exactly where it goes. Flow name, validate-order-subflow. That is the only mandatory field on this component. Target and target value below it are optional. Use them only when you want the result stored in a variable instead of replacing the payload. Leave them empty and the subflow's payload becomes your payload. So let us actually go inside it. This is validate-order-subflow, opened in its own tab. Notice what is not here. There is no error handling section at the bottom. That is not an oversight. A subflow is physically not allowed to have one. It has no error handler of its own, ever. Whatever fails in here is handled by whoever called it. The first thing inside is a choice router called validate request. It is doing the job the name says. It inspects the incoming payload and picks a branch. Nothing has failed yet at this point. This is deliberate validation, not accidental failure. And here is what each branch does. It raises an error on purpose. 4 raise error components, stacked. This is the single most important idea in the whole module. Errors are not only things that happen to you, the good ones are things you declare. You decide the moment, you decide the name, you decide the message. Every one of these becomes a clean, catchable error type instead of a random null pointer 3 components later. Click the first branch and the condition is right there. Is empty. Payload.customer ID. Plain language: if the caller did not send a customer ID, take this branch. That is a business rule written as a boolean, and in a second we will see the error it raises. Now we come back out of the subflow, into the main flow, and land on step 3. A transform message called a map to backend contract. The name is doing real work. It tells you this component exists to convert our shape into the backend's shape. And because data weave runs here, this is one of the classic places a Mule : expression error is thrown. Here is the script. Customer ID and amount are copied straight across, but look at the last 2 lines. Currency, payload.currency default $USD . Lines, payload.items default empty array. Those default keywords are not styling. Without them, a missing field gives you null. Null goes to the backend. The backend rejects it, and you are debugging an HTTP 400 that was actually a mapping bug. Defaulting in data weed is the cheapest error handling there is. Step 4, and this is the one that actually matters to the business. An HTTP request called create order. Up to now every failure was ours, our validation, our mapping. From this component onward, failures belong to somebody else's network and somebody else's server. That changes how you handle them. So let us read its configuration properly. First field, configuration. It points at a global element named orders_backend_config, and Studio shows you the resolved base URL underneath: https orders-backend.internal, port 443. This field is mandatory, and notice the naming. The config is named after the system it talks to, not after the flow that uses it. That is the difference between a config you can reuse and one you copy. Then method and path. Post/orders, both mandatory. Path is relative to the base URL in the config, which is why you never repeat the host here. If you find yourself typing a full URL into the path field, your global config is wrong. And this is the tab almost nobody opens. Error mapping. It is optional, and it is the most underused feature in Mule error handling. It lets you say, on this specific operation, an HTTP:/bad request is really an app:/validation. You translate a transport error into a business error at the exact point where you still know what it means. Do that here and your handlers downstream stay clean. Step 5. And now we get to the interesting part. See this box drawn around the next component? That is a try scope, and may I name it try with continue so you can read its behavior from the canvas. A try scope is a miniature flow with its own error handler attached. You wrap something in a try for exactly one reason. You want that step to be allowed to fail without taking the rest of the flow with it. And what did he choose to wrap? An HTTP request called publish audit event. Think about what that is. It is a notification to an audit service. It is nice to have. It is not the order. If the audit service is down at 3 in the morning, the customer's order is still perfectly valid. Bad judgment. This step is optional. That step is not the whole design decision behind a try scope. Its configuration is audit_service_config, a completely separate global element from the order backend. Post/events. Keeping them separate is not tidiness. It means the audit service can have its own timeout, its own connection pool, and its own retry policy without touching the connection that takes people's money. And the body it sends, event, order_created, the order ID and the correlation ID. That correlation ID is going to appear again and again in this module. It is the single string that lets you find one customer's request across your API log, your audit service, and your backend's log. Put it in every outbound call. Now step 6, the handler attached to that try. Read the header. Audit failure is non-fatal. On error continue, type any 3 facts in one line, visible without clicking anything. That is what a good display name buys you. On error continue means, catch it, deal with it, and let the flow carry on as if nothing went wrong. The caller will still get a 201. Inside that handler there are 2 components. The first is a logger named log degraded audit, and this logger is the thing that separates a professional on error continue from a dangerous one. If you catch an error and write nothing, you have swallowed it. The flow succeeds, the data is incomplete, and nobody ever finds out. That is the failure I opened this video with. So read what it actually logs. Audit publish failed. Continuing, then type equals error.errortype.identifier with default unknown, then correlation ID equals correlation ID. 2 pieces of information, and both are searchable. The type tells you what class of failure it was. The correlation ID tells you which request. The default unknown is there because on some system errors error type can be null, and a logger that throws inside an error handler is a very bad day. And the level is warm, not info, not error. This is a real convention worth adopting. Info is normal traffic. Warn is we handled it but the result is degraded. Error is the caller did not get what they asked for. If every handled error logs at error, your alerting becomes noise and people start ignoring it. The second component is a set payload called keep order payload, and its value is vars.order response default payload. Here is why it has to exist. When an error is raised, the payload at the point of failure is replaced by the error. If you do nothing, your flow continues carrying an error object where the order used to be, and the next component quietly maps garbage. On error continue does not restore your payload for you. You restore it. This one line is the most commonly missed step in the entire pattern. Step 7. We are out of the try scope and back on the main line. A transform message called build success response. And notice what just happened. Whether the audit succeeded or failed, we arrive here either way. That is on error continue doing its job. The flow does not know, and does not need to know. The response is 4 fields: status success, the order ID from the backend, the correlation ID, and a timestamp. Look at the third one. The correlation ID is returned to the caller. That means when a customer phones support and says my order failed, they can read you a string, and you can find that exact request in your logs in about 4 seconds. Design your success response so it helps you debug the failures. Step 8. The last component. A set variable named 201 created. This looks trivial and it is not. It is a pattern. Name, HTTP status. Value 201. The HTTP listener's response section is configured to read vars.http status, so the actual status code of this API is decided by a variable, not hard-coded in the listener. Now the error handler can set the same variable to 400, or 404, or 503, and the response section never changes. One place decides the status. That is the design that makes the rest of this module possible. One last thing before we leave the overview. Look at the tabs across the top. There is a separate file called global-error-handler. The flow we just walked has almost no error handling code in it, because the handler is not stored there. It lives in its own configuration file, and the flow only references it. Let us look at what is inside. This is a subflow called error-response-builder, and it is a 4-step pipeline. Resolve error from catalog, which turns the error into a status code and a safe message. Build error response, which shapes the JSON. Say HTTP status, which writes that same HTTP status variable. And log by severity, a choice that sends client faults and server faults to different loggers. One subflow, reusable by every error handler in the application. And underneath it, the error handler itself. Global_error_handler. 2 blocks: client fault 4x hex and server fault 5xx, and both of them do the same thing. Call that builder subflow. No logic is duplicated between them. The only difference is the condition that decides which one runs. That is the architecture. Now let us go and understand every piece of it properly.